Alright, follow-up video. How to actually open this. Still haven't completely taken the cover off, but it seems like you pry down on the tabs this way and just do that a whole bunch. And that at least gets the edges off, like so. And come and do it to this side as well. 1, 2, 3, 4. So now I guess it's just here. Let's see. Yep, okay, there's one. It's a really nice cover. Seems like polypropylene, but we'll see when I get inside. Why don't you want to come off? Oops, can't push down on it. Alright, there we go. Let's do the same over here. That came off. Okay, so now you just gotta do it all at the same time, and then it comes off. That seems like polypropylene. Yep. Nope, that's polycarbonate. Wow. That's gonna be a really solid cover in polycarbonate. Okay, well, we're inside. And let's see if this is actually a battery management system, or it doesn't seem like it. It seems like we're just breaking each cell out, except that it runs through, so it probably can. We're going to grab our T20 and T25 driver, but I have to go get it, and my microphone might break out because it's actually in a different part of the house. So if it does, it does, and if it doesn't, it doesn't. Again, these are 0 effort posts. And it's very much trashed in the garage here right now. We basically took everything out of the U-Haul truck and threw it in the garage, so the cars are all outside. And now that I look at it, I think that's probably a T20. We'll see. Well, if you couldn't hear me before, you didn't miss anything. And if you could, thanks for listening. Definitely not a T30. It is a T20. Cool. So let's take all of these screws off. It's nice that these are screws. This has got to be some kind of isolated CAN bus with an ADC. And it looks very simple compared to the Titanate ones, the SCIB modules. I don't know if that's pronounced SIB or not. That'd be neat if this was a easily reversible, thing. We could reuse this PCB over CAN bus or whatever. But it is tab welded, so if one of these cells dies, you're not going to be replacing it. Probably. So I am not doing any post-production on these videos. Probably need to be a little bit safer there. So you get to watch me unscrew these screws by hand because I don't have a drill in here. I don't really like to use drills anyway, for the most part. Okay. Part of the discovery process. Seems like there might be a couple of temperature sensors in there that are plugged in with the connector on the side, maybe one underneath too. But it certainly looks like this battery is designed to handle very high current. These tabs are 200, 300, 400 amps, which would be, only 400 amps would only be a 10C discharge, not even 10C discharge. So yeah, I think this module is going to be able to handle 75 amps of regen and 140 amps of assist. That would be my educated guess there. We will, of course, still test it. I paid for the 48S. I think I paid something right around $1,000, maybe 1,100 bucks. I don't remember again. It's been a very long couple of weeks. So yeah, the back of this PCB is unremarkable. There is very little revealed. Maybe when we flip it around, we'll find technological goodies. Or it could just be traces out, although it seems odd again because we have two separate connectors. So, it seems like we're going to need to unplug this. And that is somehow secured. That there are these smaller T5s or whatever. It's possible that those are holding it on. I am not being very careful tonight. Sorry, I think I hit the camera too. Okay. Standard boilerplate warning text about don't try this at home. Alrighty. Being safer. Let's see, what size was that anyway? That was a T6. Playing along at home. I think this probably just holds the connector on, but we'll see. It might secure this to the plastic piece underneath. And yeah, I think it just holds the connectors on. Okay, what now? Just kind of fiddle with it until it comes off. There's definitely something here. There's a tab right there, hidden in plain sight. So if we take that tab off and break it, because that's what just happened, then this pulls up. And presumably there's one over here as well. There is, but it's already been pulled up. So there's something else. And the tab goes in there. All right. Okay, and then we've got those two temperature sensors, maybe. And that is it push fit? How does that work? So much easier once you know. Okay, yeah, that is a connector. It's a push fit connector. Okay. Okay, well that is all capacitor coupling and fuses. So in fact there is no logic whatsoever on this PCB. Now, really neat thing, because we already have this footprint, we could make an LiBCM attachment. This is not happening anytime soon. That replaces this PCB. Has an ISO SPI bus with carry through. That could be really cool. Again, that is an extremely forward-looking statement. For some reason there's conformal coating here, but not, I mean at the connector you'd think they would, they're doing the conformal coating before they put the connector on. Really they should be doing it after they put the connector on. Of course they can't rework it. There is a high voltage isolation cut here that you probably can see. Maybe not. It's not on the other side. But yeah, this is all just fuses and test points. In fact, there's not even a fuse here, so seems like, yeah, they have, this is useful on multiple configurations. And I'm glad I took a video because, oh, you can only put it on one way. So there's definitely different configurations of this module because, you know, this one here, you can see they've depopped a fuse here because this isn't screwed onto anything. Or maybe it is. No, it's not. So they can basically populate fuses on this PCB to support any configuration of these modules. This is certainly a 12S1P. It's weird because they would need to make a module that was like 24S1P to need to sense more places. But at the end of the day, this PCB is not doing anything at all other than just passively routing the taps to this connector. And also somehow to this connector, to be determined. It's only a 10-pin connector on both sides, so Of course, with the 12S, you need 13 pins to measure the voltages. And then, of course, there's temperatures as well. It seems like the holes that are cut in these is just for the vents, in case this module vents. The vent tab here must be like that. It allows it to vent up through the PCB rather than back on the cell. That's actually required. You can't obstruct the venting back to the cell. We've got a nice little funnel here too, and this presumably polycarbonate as well. So yeah, there's no logic on here other than just routing out 2 temperature sensors to 2 random modules. Cannot take these apart, but they are volumetrically very, very dense. Again, you could put the LTC 6804-1 on here, and then use ISO SPI in a daisy chain to have it all contained on here. So that could be just theoretically an LiBCM option. Again, extremely forward-looking statement. This is the first time I'm looking at this module, but again, there's nothing on here. So at this point, I guess what I would say is if this fits in the OEM bay, then it will work with LiBCM. Again, that's also a forward-looking statement. I will be doing that. I don't know when, but this looks like a very well done module. And honestly, I'm not terribly. I think Ford makes a lot of really shoddy stuff, and Chevy is even worse. GM is wow. Okay. Anyway, this is well built. I don't know, of course, about the chemistry. We'll test that. But this is a well-built product. I wouldn't be surprised if actually this was farmed out to someone who actually knows what they're doing with batteries and how to tab weld them together. These are some really sick tab welds. This is a full round, probably 10 or 12 millimeter tab weld. That's a several thousand amp discharge. Anyway, you can see that it has compression clamps on the side here. I don't know how. I think that it's just tab. Yeah, on the side it's actually just welded. So you're not going to be taking this module apart. So then the only other thing is, what the heck is this? This is just some lipstick to hold something on. Yeah, it's just standard tab inserts. So you could pull this out. This is just a trim piece, and this is a plastic part. It's palm. So yeah, that's that. This is something OEM. You could maybe mount something there. Again, you can see this compression plate. This is actually CNC'd aluminum, not cast. So that's an expensive part there. Yeah, so that is the mechanical introduction. Thanks for watching along. I know it's a half hour of your time. It's a half hour of my time as well. Saved me a lot of time doing it that way. Final things here, we'll look at some of the labels on the side. Again, this is a Ford Motor Company. This was manufactured, I have no idea when. Let's see, battery cell module 12S1P, MPO217NS002A, 2 kilowatt hours. That's respectable. That's, a 12S, that's going to be nominally 44 volts or whatever. So that'll be a 4.1 times 12 times 4, because you have 4 modules. That'll be a 197 volt system. It'll work just fine with LiBCM. So it's just mechanical fitment. So what fitment is that? That is attaching each of these cells to a wire harness. And what I will end up doing on these, to make it simple, is I'm going to replace this PCB with a similar PCB with a similar mechanical pattern that just goes to a ribbon header here. That way I can plug a ribbon connector in there. Alternatively, we could find this connector, but this is what I've just mentioned is so easy to do that it's really not worth doing another way. Theoretically, we could also put the temperature sensors out there. Probably not going to do that. Probably going to just use the OEM temperature sensors that LiBCM already uses. I have not proposed any final solution here at this point, but it seems like making this a ribbon connector on the end is much easier. this is a bit, maybe, I don't know, you could make that one layer, and then it would be a very cheap PCB, a few dollars, and then you could just spit as many of those out as you wanted. You'd need 4 per 48S car, and you'd be able to use ribbon cables to plug into the existing LiBCM. So what I had proposed previously was putting the 6804-1 on here. That, again, that's not happening anytime soon. For now, LiBCM will use the battery management circuits that are built into it, and so you will need to connect a replacement PCB here to LiBCM through ribbon headers, and those will be very, very easy cables to make. So this is a very viable solution. If someone can fit these in their car before I do, I'd love to watch, see how you do it. If not, I will make a tray, probably using 1/4" aluminum as a base, and then make that bolt into the OEM tray, either standing up as I showed earlier or down, probably just sitting down if it'll fit in the bay. Yeah, thanks for watching.